Welcome to Excellent Grades Academy. This is Dr. Byson EM. Today we are continuing with tutorial sheet 2, and this is the last video on tutorial sheet 2 because we are answering the last question, which is question number 3 and all its constituents. All right, so now I am introducing a very exciting feature called memberships on my channel, and this membership will include a lot of perks such as accessing all my videos in all the courses. Please kindly join my memberships and let us learn together. All right, so this tutorial sheet is from the University of Zambia, and let's get into this video. Okay, organic chemistry, very interesting course. So question 3 says, which product or products would you expect to obtain from each of the following reactions? In each, give the mechanism, whether it is SN1, SN2, E1, or E2, by which the product is formed, and predict the relative amount of each product. Say whether it is the only product, or it is the major product, or the minor product. So we've got 5 stems to this question. A. All right. So what we are concerned with, or really focusing on, is the mechanism by which these reactions happen. So let's do them one by one and see. Okay, so number 1 is this question here. So we have 1, 2, 3, 4, 5, and then the bromine is attached. And then, okay, our nucleophile here is ethoxide. So this is ethoxide. And then we have ethanol here. And the temperature is 50 degrees Celsius. Like that. Okay. So now, when we look at our alkyl halide here, this is a primary alkyl halide. And our nucleophile here is not a bulky nucleophile. So this reaction, since this is a primary alkyl halide, will happen mostly by SN2 reactions. So this nucleophile is going to attack from the backside, and this is going to leave. So what we're going to have or form is this product here. 3, 4, 5, and then this will be attached to the ethoxide here. Okay, so this is our product that is formed. So this is 1, 2, 3, 4, 5. So this is ethyl pentyl ether. So this is ethyl pentyl ether. So this will occur by SN2. So the mechanism by which this occurs is SN2. So this is an SN2 reaction. Now, this is not the only reaction by which this product is going to form. So the other mechanism by which this can react is this one here. So 1, 2, 3, 4, 5, the bromine, and then you've got the ethoxide here. The ethoxide is a base. So you know that this is an alpha carbon here. Alpha carbon. This alpha carbon is attached to this beta carbon. So this carbon here is a beta carbon. Okay, it's a beta carbon. This beta carbon has got a beta hydrogen. This beta hydrogen is acidic. So this base here is going to be attracted to this beta hydrogen that is acidic, and it's going to get it, and then these electrons are going to collapse here. When those collapse here, the leaving group will leave. So this mechanism is an E2 mechanism, which will result in this product. 1, 2, 3, 4, 5, like this. So this is an E2 mechanism. Okay, so this is an E2 mechanism, and there's going to be ethanol that is formed at the end of the day, like that, plus the bromine that left. So there are 2 mechanisms that can happen for the first compound there. The first one is ethyl pentyl ether, which was formed by an SN2 reaction. And the other one is this 1, 2, 3, 4, 5. So this is 1 pentene. The other one is 1 pentene that is formed by an E2 reaction. So when you compare these two products that are formed, the one that was formed by an SN2 reaction will be the major product. So this is the major product. Why? Because the alpha carbon was a primary carbon, and the base, the nucleophile here, was not a bulky base. It was a strong base and it was not a bulky base. So this will be the major product. The ethyl pentyl ether will be the major product, and the 1 pentene will be the minor product. So this will be the minor product. So those are the two products that are formed from the first compound by SN1 and E2 reaction mechanisms. Let's look at the second compound. All right, so this is very interesting. The second compound was this 1, 2, 3, 4, 5. So it was the same one bromopentane, but this time around we're using this base, tet-butoxide. Now tet-butoxide is a bulky base, so tet-butoxide, alcohol. Okay, so tet-butoxide, this base is a bulky base. So this bulky base will react mainly by an E2 reaction. Okay, so an E2 reaction, this tet-butoxide will come and will get this acidic hydrogen. This will collapse here and the leaving group is going to go. So what you form is pent 1 in. So this will be the major product. The major product. This will occur by an E2 reaction. There's another product that is going to be formed when an SN2 reaction occurs. Okay, so an SN2 reaction can also occur, but the SN2 reaction will result in a minor product. So this will be the minor product. Why? Because this base here, this nucleophile, is a bulky nucleophile. So for it to come and attack at the alpha carbon here, although it's a primary alpha carbon, is going to be a little bit difficult because of the steric hindrance that the bulkiness of this nucleophile is providing. So the E2 reaction is going to happen faster than an SN2 reaction. Okay, so this is the same substrate that we used in the first question, but the nucleophiles are different. In the first question, we go back. In the first question, the nucleophile was not bulky, so the SN2 reaction was going to happen faster than the E2 reaction. That's why the product that we obtained from an SN2 reaction was the major product, and the one that we obtained from an E2 reaction was the minor product. But when we use a bulky base, the products that we get from an E2 reaction is the major product, whilst the product that we get from an SN2 reaction is a minor product. The one from the E2 reaction is the major product. The one from an SN2 reaction is the minor product. Okay, let's do question 3. Question 3. So we have this. We have this substrate here. Okay, so this is 1, 2, 3. If we were to name this, this is simply 2-bromo, 2-methyl, propane. 2-bromo, 2-methyl propane is reacting with tet-butoxide. Okay, so now this is a 3rd degree alkyl halide. So what is going to happen is that this side group, this leaving group, is going to leave on its own, and it's going to have a carbocation here. Okay, so this carbocation, since this base here is a bulky base, it won't readily come and attack this carbocation, but it will come and readily remove this hydrogen here, which is acidic. This is a beta hydrogen. Okay, and then these electrons are going to collapse here. So the product that you are going to form as a major product is this product here. So this will be the major product. This major product is formed by an E1. So an E1 reaction mechanism. The other products that can form is by an SN1 reaction mechanism, where this one will come and directly attack the carbocation. So you give us it will give us that. Okay. It will give us that product. So this is the major product and this is the minor product. Why is the one occurring by SN1 a minor product? Because look at this. This is a tertiary carbocation. The nucleophile is also bulky. This is state butoxide. It's also bulky. So for the bulky group to come and attack this carbocation, there's going to be a lot of steric hindrance. That's why this is the minor product. But it will easily come and get this acidic hydrogen here to form a double bond. That's why the product that is occurring that is forming by an E1 mechanism is a major product, and the product that is forming by an SN1 reaction is a minor product. So that is how the products for this reaction are going to occur. Let's look at the fourth question. So the fourth one is this compound here. 1, 2, 3, 4, 5, 6, 7. And then you have a chloride here. What's the name of this compound? It's 1, 2, 3, 4, 5, 6, 7. So this is 3-chloroheptane. And this is reacting with methoxide. Sodium methoxide. Okay. So now, the reaction mechanisms that can happen here is that this base here can come and collect this acidic hydrogen. This will collapse here, and then this one will leave. So the products that can form is 1, 2, 3, 4, 5, 6, 7. You have a double bond here. The other products that can form is that instead of getting this acidic hydrogen, it can get this acidic hydrogen here. So when this acidic hydrogen here is obtained by this base, these electrons will collapse there. So instead of the double bond being here, the double bond will be there. So this will be 1, 2, 3, 4, 5, 6, 7. The double bond will be this side here. The other product that is formed, so these products that I've written here are being formed by an E2 reaction. So this is an E2 reaction mechanism. The other reaction mechanism that can form products is an SN2 reaction. So where this base will act as a nucleophile and it will go and attack this carbon here, the alpha carbon. When it attacks this alpha carbon here, this leaves. So what you are going to have is this product here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7. So where the leaving group was, that's where this is going to be. So this was going to occur by an SN2 reaction. So the major product among these three products is this one. So this is the major product, followed by this one, minor product, and then this one is the least. All right. So this hydrogen is easily gotten by this than this hydrogen. Okay. Number 5. We have this alkyl halide here, 2-bromo 2-methylpropane reacting with a methoxide, sodium methoxide. The reaction mechanism that can take place, number one, this one will go on its own, form a tertiary carbocation. This tertiary carbocation that is formed here, this nucleophile can come and attack here. Why? Because this nucleophile is not bulky, so it will come and easily attack the carbocation and form this ether here. Okay. Or the other product that is formed, so this will occur by an SN1 reaction. The other product that can form is that this one, this base here will come and attack the acidic hydrogen. This will collapse here. So the other product that is formed is this. So between these two products, this is the major product. And then this is the minor product. Why? Because this base here is not bulky, so it can come and easily attack the carbocation. So this is an E1 reaction. So that was question A of part 3. That was question A of question 3. This is how you go about this. Let's go to part B. Part B says provide the starting materials for the preparation of the following compounds via SN2 reactions. So the first one is this one here. So in order to create this product, the starting materials were like this. So the mechanism in order to provide this product here was like this. You were going to react 1 iodopropane with this cyanide ion, and then this one was going to attack from the back. This one was going to leave, and then the reaction mechanism, the transition state, was going to be like this. This was breaking, and this one was forming. And then you end up with this product here that we have. So this was the reaction mechanism in order to form this product by SN2 mechanism. This was how it was supposed to be done. Okay. So this was part 1 of part B. Part 2 of part B, how were you ending up with this product? What were the starting materials in the SN2 reaction? So the starting materials in the SN2 reaction for this product was this one here. So when you look at this, there's a positive charge here and there's a negative charge here, meaning that this is an ionic compound. What this simply means is that these in solution are existing like this. So they're existing like this. This one here is attached to the methyl, and then plus the iodine is alone like that. So the starting materials in order to form this compound in solution were this. We reacted this compound here that had a lone pair of electrons with methyl iodide, and then this attacked this alpha carbon. The iodide left, and then we ended up with this. So we ended up with because the hydrogen here is bonded to 4 things, it has got 4 bonds there. The nitrogen is positively charged, and the iodine here that left with the electrons is negatively charged. All right, so these were the starting materials in order to make this in solution, which is this here. All right, so B3, by an SN2 mechanism, what were the starting materials in order to form this product? So in order to form this product, the starting materials were, you simply had this, and you reacted it with this guy here. So this one served as a nucleophile, came and attacked here, and this guy left. So what you had at the end was this, which is this one here in solution, okay, plus this guy that left, okay, this guy that left, okay. So for SN2 reactions, we know that SN2 reactions occur in polar aprotic solvents. So in all of these reaction mechanisms that we are writing, just write a solvent underneath. So acetone is a polar aprotic solvent. For this one, you can write DMSO, okay, dimethyl sulfoxide. And then for this reaction, we can write tetrahydrofuran. So just indicate the polar aprotic solutions that were present when these reactions were taking place. And do not forget, in all of these reactions, show your transition states. I left them out, but make sure that you show the transition states by which these reactions are occurring. So that was part B of question 3. Let's go to part C. Say and suggest a most likely mechanism to account for the product of the following reaction. So how do you think this reaction went in order to get this? All right, so now let's look at the mechanism. So the mechanism that happened here was that, so you have D here, okay, like that. Now, when you look in solution, this one here is phosphoric acid, and you know that an acid is a proton donor. So I'll write it like this because I want it to donate protons. And this guy here is a base. So this guy will get this hydrogen here, and then it will break like that, and then solution will be like this. So there's D here. So this one will be protonated because it would have gotten one hydrogen from here. So the oxygen is positive here. When the oxygen is positive, this will leave as water. Okay. So if that leaves as water, this will form a carbocation here because this group has left. It will form a carbocation. Okay. So the carbocation that it forms here, there's going to be a rearrangement. Why? Because this carbocation is on a secondary carbon, but there's a carbon here that is a tetracarbon. It's attached to 4 things. So there's going to be a methyl, a methyl shift, okay, a methanide shift. So this methyl is going to shift to this carbocation. So the compound that you're going to end up having is this one here. The carbocation will move here. This methyl shifted here, which is this methyl here, and the carbocation which was here shifted to there. Okay, so the carbocation is here, but you know that in solution you've got this guy here that left, the water. So the water will act as a base, and this water that acts like a base will come and get this acidic hydrogen. This acidic hydrogen is going, not this hydrogen, rather, it will get this hydrogen that is here. There's a hydrogen here, so forget about this. It will get this acidic hydrogen, and then these electrons that were touching the hydrogen are going to collapse to here. So what you're going to have now is this compound. there, and then there's a D here. So this is the mechanism by which this product was formed from here. So when this water gets this hydrogen, it will be an acid. It will be an acid like this. So you got your product and the acid here. This acid here goes back. So this is the mechanism by which this product was formed. First of all, there was protonation. After the protonation left, the protonated group left, formed a carbocation, and then there was a methanide shift here. After the methanide shift happened, the carbocation moved here, and then the water, the base, went and got this hydrogen that was here, the acidic hydrogen, and then these electrons collapsed here. There's a double bond here. So that's how this product was formed using these 13 materials. Okay, so that was part C. Part D and the last part of question C says your task is to prepare stellene by the following methods. Which one would you choose to give the best yield of stellene? Okay. So now you see these products, these 13 materials are different at one point. This guy here is a primary alkyl halide. Alkyl halide. This one is a secondary alkyl halide. Secondary alkyl halide. So now they're saying which one is the best method? Which one is the best method to yield this product here? Okay, so if you were to write the reaction mechanism for this reaction, it would be like this. And then you've got potassium hydroxide there. Okay, potassium hydroxide there. So in order for us to have this product, what did it mean? That the potassium hydroxide would attack this hydrogen and this would collapse. This one goes there, and then it will give us this product. And then for 2, so this is 1. For 2, the reaction mechanism would be this. In order to give us that, this will come and attack this one, and then this give us that. That will give us that. So the product would still form like this. So now they're telling us which one is the best. Which one is the best between these two? So the one that I would choose to yield the best amount is this one here, part 2. Why? Because this one, the base, will easily come and get this hydrogen, and this reaction won't compete very much with an SN2 reaction. The reason why it won't compete very much with an SN2 reaction is because for an SN2 reaction, this will have to come and attack here. And in order for it to come and attack here, it might interact with this group here. So there will be steric hindrance. So E2, this is E2. E2 reactions will take precedence in this reaction. But for this reaction here, SN2 reaction can easily occur because this is a primary alkyl halide. So SN2 reaction will come and occur. So the amount of styrene that is produced is going to be affected because most of the product will be by an SN2 reaction and not an E2 reaction. But for this one, SN2 reaction products will be very few compared to E2 reactions. So this reaction mechanism would produce a lot of sterline compared to this reaction mechanism. Why? Because this is a secondary alkyl halide which sponsors SN2 reactions, which sponsors E2 reactions more than SN2 reactions, and this is an primary alkyl halide which sponsors SN2 reactions more than E2 reactions, and we want to produce this product by an E2 reaction. So we're going to prefer using a secondary alkyl halide compared to a primary alkyl halide. All right, so that was the end of our video. I'll repeat, join our memberships and receive perks that are going to improve your grades. You can register with us on +260 975 97790 for all your organic lessons, starting from stereochemistry until alcohol. I'll see you in the next video.